nth roots. That's how you say that if you didn't know there at the top of your page. And n is just a variable, so it means square roots, third roots, fourth roots, fifth roots, sixth roots, and so on. Any roots. Today's section is a little bit difficult to teach, and it'll be, for some of you, a little bit confusing. I'm going to try to make it as easy as I can. It's not really difficult. It's just that we're learning rules to help you solve problems that you already know how to solve, some of. But they work for roots like fifth and sixth roots. You're used to solving square roots. So some of the problems that you do today will just be the square root of 16. Well, you know how to do that already. You've done it many times in the past. But there's rules that go along with solving these radical problems. And that's what we're going to go over today. So first of all, what are the parts of the radical? We have three parts there. This sign, of course, just being the radical sign. The number underneath is called the radicand. And then whatever root you're taking is the index. So you may have seen that stuff before, that terminology before. So we're just going back over that kind of as review, hopefully. So like I said, you're used to seeing problems like the square root of 16. And you'll again have that problem in your homework today. What is the square root of 16? 4. We know that we would write that as 4, but something that we've done in the past, we might have had x squared equals 16. How do we solve that? Square root both sides, and what do we get for an answer then? X equals plus or minus 4. So what is the difference? Why do we only put 4 here, and over here we put plus or minus 4? Yeah, this one can. This equation, that's why, that's a good observation, that no matter which one we plug in there, when we have x squared equals 16, you can plug in 4 or negative 4 there, and it makes the equation true, right? Over here, why do we only list positive 4? Because the positive one is the principal root. So that's probably a vocab word you haven't seen before. That is, the positive one, when you're doing an even radical, you're going to get a positive answer, the principal root. We also did problems like the square root of negative 16. What do we know about that? It's imaginary. So today, you're not going to have to figure out or write for I for your answer there. All you're going to have to write is that there's no real root, which we know we've done that before. So the index, this number up here, and whether the b is positive or negative will tell you what kind of answers you're going to end up with, whether it's odd or even, and whether your b is positive or negative. So if you look at the table on page 403, this will be of great benefit to you while you work. So you really need to understand that table. Yesterday, first hour, the class actually did very well with the problems, but the only thing that I ever had to do was walk around and show them back to the table. I'm going to write the table up here in a little bit different format, and you can use either one in your homework, but I promise you will need to use it for your homework. So make sure you're either going to flip back to the table or write down what we've got up here. So again, it's the nth root of b. Obviously, n and b are variables. They can be any number. So the first type of problem is when n is even. So when the index number is even, then we have b greater than 0. What does that mean about b? Another way to say that. It's positive. So if n is even and b is greater than 0, you will have one positive and one negative root. But you're only going to list the positive one. You're only going to list the positive one. That's going to be the principal root. So that's just like the square root of 16 that we had up here. What's the index there when there's not a number, you know? What is it? Right here. Not 1, 2. There's not a number, you know, it's always the square root. So this was even and this was positive. And so there are 2 roots that go in there. We only list 4. We only list the principal root. So that's what that one represents. And then if b is less than 0, so again, your index is even and your b is negative, what kind of roots will we have? That was this one right here. You got an even index and your b is negative. What kind of roots? So that's all you have to write there. So those rules, these right here, work for anytime your index is even. So it's square root, 4th root, 6th root, 8th root, and so on. So the other possibility there is that n is odd. So most of the time that's going to be the cubed root, but it can be the 5th root, 7th root, and so on. So if n is odd and b is greater than 0, again, that means n is odd and b is positive. So as you're working your homework problems, that's what you'll have to check when you get a problem like this. Okay, n is even there, so it's going to be one of these 2, and b is negative, so now I know this is the one I'm dealing with. So that's how you're going to use the table as you go through your homework. So if it's odd and b is greater than 0, you have one positive root. And no negative root. Basically what that means is your answer has to be positive. So whatever you get for that cubed root of 27, it's going to be positive, not negative. And then if b is less than 0, it's the exact opposite of that. You'll have no positive and one negative. So revert to either that or the table, whichever way you want to as you work through your homework. So basically what this means, what this one means is your answer is going to be positive. What this one means is your answer is going to be negative when you get done. Those are the rules, and now we'll work through some problems using those rules. They might have plus or minus square root 25. So that sign out front, that doesn't have anything to do with what this answer is going to be. It might change what this answer will be later, but you still solve this part the same as you would any other time. So if we look up at the table, and again, you don't need to on this one, but just for practice sake, is our n even or odd? It is even, and is this number positive or negative? So this is the one we're looking at, and it says we have one positive and one negative, but we only list the principal root there, which is 5. And then you just bring down, in this case, the plus or minus. Same problem, we'll just put a negative out front this time though. So again, it's the same thing up here. We only list the positive one, which is 5, and then we bring down the negative. So our answer ends up being negative 5. Square root of 25 x to the 4th. So we know how to do the square root of 25. What is that? 5. How do we simplify that variable with the exponent? How do you get it? By this, which is called the index. So for variables, you divide the exponent by the index. Divide the exponent by the index. So the index is 2, the exponent's 4. 4 divided by 2 will give you x squared. With a problem like this, it's kind of like squaring a binomial. There's specific rules you have to know. You're not going to do anything if you've got a plus or a minus problem in parentheses like this one, and you will have in your homework, so make sure you remember this or have it in your notes to revert back to, but you're not going to do anything with this. These problems are actually quite simple. All you're going to do is change that exponent to whatever it would need to be. So we still have our negative out front, and we're solving this. What do we do with the exponent there? Divide by 2. So all you end up with is 2x plus 3. That's all raised to the 4th power. You don't do anything with that binomial if it's addition or subtraction. Fifth root of 32x to the 15th, y to the 20th. So we have an odd. N is odd for this problem, and is it positive or negative? Positive. So if N is odd and B is positive, we should end up with one positive root, no negative ones. So all that tells you is when you do the fifth root of 32 there, you end up with a positive number. What is the fifth root of 32? How do we figure that out? What? Somebody said it. It is 2. 2 times itself 5 times will give you 32. So 2, and then what do we have for our x exponent? 15 divided by 5 will give you x to the 3rd, y to the 4th power. A lot of these problems are pretty simple like that. We've already done one like the last one there, square root of negative 9. What do we get? No real. Yes. Always. There'll be a lot of those because they're never going to put the 2 in there. So.
Can I have one?
Okay, what? If it were 1, it would say 1. It would have the 1. So it is a key. I don't think we'll have it. 8th root of x to the 8th So what do we end up with here? 8 divided by 8 would give us x to the first power. But let's look at our rules here. So our n is even, and our b is positive. So if it's even and b is positive, what does that tell you your answer has to be? What did we say? It has to be positive. So for a problem like this with a variable, you don't even have to put the x to the first. But you need to have that in absolute value. Because what did we just say the answer has to be? It has to be positive. So by putting that absolute value around that, you are saying it has to be a positive number. Another way to remember to do that is anytime that your index here is even and you end up with an odd power, that's when you have to put it in absolute value. If your starting index is even, and of course we ended up with 1 for our exponent, that's an odd number, we have to use the absolute value. The fourth root of 81, a plus 1 to the 12th. So the fourth root of 81 times a plus 1 to the 12th. Is the 81 being taken to the 12th power? No. So we just need to check here. Can we do the fourth root of 81? What times itself 4 times? 3 works? Yes. So we have an even power, and our answer and our b is positive. That means our answer has to be positive. Ashley. Means our answer has to be positive. Is that 3 positive? So we need to put the 3 in absolute value. Is it positive? Then why would we need to say that it's positive? This being a variable, you could plug in -5 right there, couldn't you? But the absolute value tells you it has to be a positive number. This 3 is already positive. You don't need to say that it's an absolute value. It's already a positive number, nothing you can do there. Here, though, 12 divided by 4, we're now going to have a plus 1 to the what power? The third. That has to be an absolute value because we have an even index and we end up with an odd exponent. So just this part needs to be absolute value. We're denoting that that has to end up being odd. You won't need to put numbers. If you end up with just a number like we did the 3 there, it doesn't have to be put in absolute value. Remember the fraction rule. You have the square root of 1/9. What did we do when we had a fraction? No, we won't have to here. We've done radicals with fractions before. What did we do in the first step? Right, split it up. So we do the square root of 1 over the square root of 9. So what is the square root of 1? And the square root of 9? 3. So you end up with just 1/3. I'm just looking through seeing things we ran into yesterday. You'll have a lot of calculator problems where it's just type this in your calculator, the cube root of 22, maybe. So how do we do cube root in our calculator? And actually, let's do the 5th root of 78. We'll do those 2 in our calculator. So where's the 5th root t? Anybody know? but I do know where to get this done. If you go to second catalog, in second, in other words, that's your 0 key. So hit second 0, brings up a whole list, very, very, very long list of all the things that your calculator will do. So we don't want to scroll down for cube group because that would take way longer. We want to hit up so that we start scrolling from the bottom up. And what you're looking for this problem, it will have a little 3. It looks kind of like that. Cube group up. So once you get there, you just push enter and it puts that cube group back to your screen. Little blinking cursor in there. You hit 22, enter, and you get 2.802. And your directions say around 2, 4, or 3 decimal places. So you'll need to have 3 places after your decimal. So that's the cube root key. This next key will work for any root. So you can choose to use that, or you can choose to use this next one that I'm going to show you. Either way. So what you have to do to type this one in is type your index first. On your home screen, you have to push the 5 first. Then hit your second 0, go back in the catalog, and you're going to go 2 above the cube group that you just went to. It's got an X in it. It looks like that. Again, it's 2 above the one we were at last time. Push enter there, and it automatically makes the 5 be your index. So all you have to do is type 78 and push enter, and you get 2.390. So you will use that like down on 37 through 48. This is where our homework is. Page 405.